Thanks for joining us. It's exciting to be able to speak with you and give you a little bit of introduction both to storage spaces at Fermilab and then also data management. So right now, you should be seeing the page for storage spaces, which is, I guess, if I remember correctly, section 2 for the training on GitHub. So as far as the purpose of this section of the tutorial, so there are kind of 2 questions that I'm going to try and address. The first one is, what are the types and roles of DUNE's data volumes? Basically, when we store data someplace, what are the possibilities where we can put it, and why would we put data or files in one location versus another location? And then the second question is, how do you actually handle the data that is being stored on those volumes? How do you find out what's in an area and what files are available? And then how do you copy those files or stream those files someplace else? So the objectives: understand the data volumes and their properties, display some of the information about a volume. So learn about the total size, how much is available or how much is used, where the mount point is, and then also a little bit about its physical location, because depending on where a disk or a storage element is located, it will behave differently. And then also differentiating between the commands to handle data in a grid accessible way versus what you can do on an interactive node. Okay, so as an introduction, in general, there are kind of 3 types of storage volumes that you're going to encounter at Fermilab. I think about them like this, that they are local hard drives, right? Hard drives that are physically inside of a computer node, network attached storage, volumes that are going across kind of a traditional internet connection. And then lastly, the large scale and distributed storage. That's storage that's kind of very specifically been constructed to handle high throughput, lots of connections, and has both great capabilities, but then also needs to be addressed in an appropriate way. So each has its advantages, its limitations. Knowing which one to use is not obvious. And knowing when you might inappropriately be using one of them is not something that's going to become apparent to you until things kind of start to break down. Also, I would like to introduce my assistant. This is my assistant, Crit. She will be visiting every now and again on my desk, trying to steal some of my tea and then look out the windows at the birds of Voltaire. Before we get started, after that introduction, I'll just stop for a moment before we go into vocabulary. Anyone got any questions so far? Anything that I've said that's not clear? And I should say that I won't be watching the chat, so I would hope someone else will be watching the chat, and just go ahead and interrupt me.
The chat. I am monitoring
Great.
the chat.
Thanks.
and all of the questions on the Google Docs as well. Don't worry about that.
Great. Okay. So there are like three terms that I'm going to be using that are in general are maybe not so common. One of them is immutable. The idea that a file could be immutable means that once a file is written to a storage volume, it can't be modified. The only things that you can do to it is read it, move its location, or delete it. And so a file that only supports immutable files is not a good choice for code or other files that you want to change or edit, right? And I'll get into some examples of an immutable file system and storage volume. POSIX access. This is specifically an acronym for the Portable Operating System Interface. And there's a Wikipedia link. And this is kind of, POSIX access is what you normally think about for the hard drive in your laptop. You can directly read, write, modify. You can use all of the standard commands, VI, Emacs, sed, and utilize it with bash scripting. It is the fullest compliance of kind of access to a hard drive, a storage volume, what have you. And then finally, grid accessible. So volumes that are only grid accessible require very specific tools and a suite of software to enable access to the files that are stored there, or to copy files from that storage volume. In general, they are not visible from an interactive node or visible from your laptop. They are kind of off someplace else, and you're going to have to either stream those files using specific protocols, or you're going to have to copy them using grid accessible tools. So now that we got that vocabulary down, I want to introduce you to the first set of storage volumes that you're going to come up against. And those are the ones that are on the general purpose virtual machines. So you may have logged into DUNE GPVM. That's what GPVM stands for, general purpose virtual machines. There are basically three types of POSIX storage volumes. So again, you can do whatever you want, any kind of access to them. They have fully mutable files on them. The first one is the home area, and it's similar to a user's local hard drive, but it is in fact network mounted. So the physical disk itself is not kind of in the same location as the general purpose virtual machine node. So it's accessed across the network. It does have a very a high speed connection, and it's got full POSIX access. An example of that would, for my home area, is /NAS home/K/Kirby. Each person's username is going to establish where their home area is. Because it is going across the network, it is not safe to store certificates or tickets there, because someone could in fact see the traffic going across the network and pull that out, and then they would have your certificate or your ticket, and then they could act as you. I should say is not accessible from grid worker nodes. It's not for code development because it's only about 2 gigabytes of storage, but you can put scripts in there. So if you were Norm and you wanted to have a script that would be run every time you logged into every single GPVM, then you could put a script in your home area, and then it would run the grid certificate generations. Again, you need to make sure not to put your grid certificate in your home area, but you can run a script from that area. And you could put a case statement in there to do one thing for DUNE and one thing for Nova and one thing for G-2 and one thing for mu-to-E. And if you're on 4 experiments, I am impressed that you have that much time in the day. But nonetheless, you can divide things up in that way. You do need a valid Kerberos ticket to access the files in your home area. And there are periodic snapshots so that you can recover deleted files. You would do is you would actually go to this area right here, NAS home/.snapshot, and then you can dig in and look for deleted files. There is no absolute guarantee that a deleted file is going to be there, because there is some churn and eventually they have to throw things away. But if you accidentally delete something and you immediately go to snapshot, there is a very good chance that you can recover the things that you want. The next example of a storage volume on the GPVMs is the locally mounted volumes. And these are physical disks that are mounted directly to an interactive node. There aren't all that many of them on the GPVMs. In general, they are basically there for temporary storage for infrastructure services. So they are like /var/temp, things like that. You can use those to store certificates and tickets. And in general, they are saved there by default with an owner read permission and other permissions. So if you do a KINit, that's where your ticket goes. Or if you're forwarding a ticket and it gets copied onto the GPVM, that's where it will end up. And the reason is because it's a direct mount. It's not going across the network, and so there's no way for someone to steal it in transit. They are very small and should not be used to store data files or for code development. And the data on these volumes is not backed up. It's really just there for infrastructure, and that's about it. The most useful storage volumes are network attached storage. And these behave kind of similar to locally mounted volume. They function similar to services as Dropbox and OneDrive. So if you're familiar with either of those, again, the idea is that there is some storage that's out there in the cloud, right? And it is attached via networking to a bunch of different computers. So it could be a GPVM. I have actually had the app and data volumes mounted on my laptop. I don't do that anymore, for reasons, but anyways, it's something that you could do. It is nice because it is fast and stable access rate. I will say they are available only on a limited number of computers and servers. So while I did mention, that they're on a number of computers, they are in general not available on grid computing. So if you submit a grid job, it goes out into the open science grid. That network attached storage that you're so used to seeing on DUNE GPVM 01 is not going to be mounted on the larger grid computing. So if you go to /DUNE app on your interactive job, and then you try and take that same interactive bash script and submit it to the open science grid, it will not work because there is no disk called /DUNE/app mounted on the grid worker nodes. I should say that similar to the home areas, DUNE app has periodic snapshots. So if you delete something, you can go back and get it, but DUNE data and DUNE data 2 do not. And so thinking about this, these are the interactive storage nodes that we have on our GPVMs. And it's a thing to kind of wrap your head around. Okay, great. Now I know where those physical disks are located, how they interact with the computer that I'm working on, and then what's the usage that I can have to get to those things. Before I move on to grid accessible storage volumes, any questions? No? Okay. So at Fermilab, we have an instance of Dcache plus NStore that is used for our large scale distributed storage. And it has a capacity of more than 100 petabytes of storage and on the order of tens of thousands of connections. The thing to think about is you as a user have access to 100 petabytes of storage, and that is a significant, I mean, it is, I would say 10 years ago, that was world-class storage. Now we are just large storage, not quite as big as Amazon or Google, but nonetheless, it is a huge amount of storage. And so accessing it or putting in requests for it to move data around is a thing that you need to be very conscious exactly how much power you have to cause the wheels to start churning. There are several different types of storage elements within Dcache, and the three type that are the most important that I'll talk about are persistent Dcache, scratch Dcache, and then tape back Dcache. I do have a discussion about resilient Dcache in here, but I should say that it is deprecated, and instead of using resilient Dcache, you should use the rapid code distribution service via IFDHcp. But I've left it in here just as a kind of as a reference. Each of these different storage elements, they behave differently. Persistent, the idea is that you write a file onto the storage volume and it is actively available for reads at any time and won't be removed until manually deleted by the users. There are no quotas on there right now, but quotas will be established in the near future. I mean, it's pretty straightforward. It acts exactly the same way that you would expect a disk to behave. The file goes there and then it is persistent until it is removed by someone actively. This is a lot different than scratch Dcache. So this is a large volume shared across all of the experiments. And when a new file is written to scratch base, older files are removed in order to make room for the newer file. And the removal is based upon a last recently used policy. So if basically the scratch volume is always full. And so whenever a file gets written there, another file is deleted to make space for that new file. In general, you have a retention. The file is going to be there for about 30 days, but there is nothing that guarantees that the file will be there. I should say that scratch Dcache is a great location to have all of your grid jobs output to, because again, there will pretty much always be space for a file to land there, and then it will be there and available for copying someplace else after you've made sure that it's valid. The scratch space will never fill up. Persistent can in fact fill up. That's one of the The bad things about persistent, it can fill up, and then when you go to try and write another file, you can just have a failure, and there's really kind of nothing that you can do about it unless you manually go in and delete some of your other files. The third type that I'm going to talk about is tape back decache, and this is a disk-based storage area where once you write a file to tape back decache, what ends up happening is NStore, which is our tape library, takes that file and ends up copying it to permanent storage on a magnetic tape. And that contents of what's written on the disk storage area gets mirrored onto NStore tape. But at the same time, the size of the disk in front of decache is not actually as large as all of the tape storage that is behind it. So a file will get written, it gets copied to tape, and then at some point it will get deleted. So files are not always available for immediate read from disk, but may need to be staged from tape first. And so checking the file status before trying to access it is one of the critical things. And we'll go into that in data management. So I have a table here of kind of a summary of the storage spaces. You know, how big is persistent decache? It's about 100 terabytes per experiment. I believe that DUNE actually now has another 500 terabytes that are going to be available shortly, but that's going to be managed by the physics groups. And so your personal user space is going to be kind of on PNFS/DUNE persistent. So you can look at this. Is it tape backed? It isn't. The retention lifetime on disk until manually deleted. Is it grid accessible? Yes. But it can only be used for immutable files with a long lifetime. So it is a great place for you to put your small n tuples that are on the order of, I don't know, say 100 gigabytes, and then you can have a bunch of samples there. Because again, that 100 terabytes is being shared by all of the DUNE users. It is not a great place for you to try and store raw data files if you have hundreds of data files. If you have one data file that you repeatedly process again and again and again, might not be a bad idea to put it on persistent decache, but at the same time, there's no reason why you wouldn't just leave it on tape-backed cache, because if you're accessing it all the time, it will stay staged and won't ever be the least recently used and get evicted from the cache in front of tape-back. Scratch, there's no quota or space limit. Again, it's an LRU eviction, least recently used. It is not tape-backed. The retention lifetime varies. It's about 30 days normally, but it is not guaranteed. Immutable files with a short lifetime, so kind of the output of your grid jobs. Once you validate them, then either decide that you want to derive something else from them, process them again to get something smaller, transfer them to persistent, or transfer them to tape-backed, or delete them, any of those. You don't necessarily have to delete them. If you don't access them, they'll go away eventually. Tape-backed, I talked about that, and the idea of you can copy something into that cache. It's on the order of a couple of petabytes, not 10 petabytes, in front of the tape library. But at the same time, as we have hundreds of petabytes of tape data, if not 300 or 400 petabytes, that nothing is going to stay there the whole time. So there's something in the chat. Is touching a file considered using it? No. I would also recommend that you not try and utilize such a mechanism to pin something in tape-backed cache. If you're processing it, great, no problem. Keep processing it and do it again and again. But in general, the idea of once every 28 days going and touching a file and keeping it in the cache because you think you may need to use it in the near future is, in Chicago, there's this thing that happens called dibs now that it's winter, where someone will shovel out the parking space on the street, and then they'll put a chair in that space and say, I have reserved this, it's now mine. And my opinion about that is that the streets are publicly accessible and no one has a right to any parking space on the street. You can't reserve it. I feel the same way about tape-back decache. If you're going to use the file and you use it every week, great, no problem. We're happy to have your file staged there forever. If you are thinking that you may want to use it sometime in the future, and so you're going to keep occupying some of the tape-backed cache disk space, I'd rather see you use your own persistent quota.
No gunfights in the street. that way.
Yes, please. That's awful. And if you are curious, DIBS is spelled D-I-B-S, and just do Google DIBS Chicago, and you will see some really absurd things. And Tom points out the same thing applies for Scratch. Touching a file isn't enough to pin it there. You really do need to read the contents of the file. Good point. Thank you, Tom. Okay, so we are moving along. I've talked about the data volumes and the app volumes. What are their sizes? It's about 1 terabyte for is the quota that you have on the data volumes. That retention policy is managed by the experiment, so we could bump up the quota, or we could take it down. The total volume for the data, I think, maybe a little bit bigger than 32, but in general, we have something on the order between 60 and 100 terabytes total on /DUNE /data or /data2. It is persistently there, but it is not grid accessible. I want to remind you about that. It is, you cannot get to, oh, I don't know why that is happening. Oh, there we go. You cannot get to /DUNE data or /DUNE app from the grid. So any other questions real quick before we start using some commands?
Nothing on the live docs.
Cool. I can't really see my screen right now. Great. My helper is in the way, but that's okay. I'll just scroll up a little. So we're going to teach you a little bit about the main tools and commands to display storage information. I don't know how many of you are familiar with the df command on Linux. It is the command that tells you how much disk is free. It's a pretty simple command. -H option gives it human readable format, and it will display a lot of information about each volume: total size, available size, mount point, and device location. So it is just simply df-h. And so the first exercise is from the output of the df-h command. Can you identify your home area, network attached storage spaces, and different Dcache volumes that are mounted there? So the first thing that you have to do, which I think in the preparation was to log into one of the DUNE GPVMs. So I'll give everybody a little bit of time to log into their favorite GPVM. Throw in the chat which one is your favorite. I will tell you that mine is DUNE GPVM 8. And then give me a thumbs up when you've gone through exercise 1. Lucky number 3. One with the smallest load. Nice. Numero uno. I wasn't going to point out to Norm that fact. I was just going to go ahead and, you know, let him log into whichever one, you know, had the highest load, and then I was going to sneak away to the one with the lowest utilization.
I'm old. It used to mean something.
I mean, it still does have a correlation, but it's not perfectly correlated with utilization.
We do have should we add the link to some point the link to the load on the machines?
Do you mean the ganglia, or do you mean?
Yeah, the ganglia. We should add that to the tutorial.
We can, yeah.
Yeah.
I think there will be some. I think that there will also be some instructions about VPN there that will be necessary, but.
Can the participant perhaps send some yes or no or thumbs up if this is all okay at that stage before we just move on, just to know if you need further further assistance in here? That would kind of help us. Okay, we have 2 thumbs up.
That's right. How many people here are are participating in the tutorial, and how many people are here as guest lecturers and helping me stay on target?
Well, some of us are learning stuff, so.
Oh, okay.
Yeah, but it really, as participants, really don't be shy to either chime in on the live doc, and so if you're stuck, so then we can really help you before we move on the with the concepts. Yep.
I'm wondering if you're preaching to the choir.
Yeah. Which is I know that there are people participating that are learning new stuff, and so I mean, even if it's 2 people, I'm happy to give this. I just want to, you know, if everybody's already done, then we can just keep going forward.
Yeah, and I also
more
want to mention that perhaps some of the new participants being here realize, okay, how come some experts need this tutorial? And so things get updated. There is always some new stuff that even some people being there for a long time are quite learning. So it's don't feel intimidated to ask questions, and you can do it anonymously on these live docs. So feel free really to say if you're stuck on something.
If not, okay, I think we'll keep going. So the thing that I wanted to point out about the df command is df is a command that utilizes the POSIX access to, or pseudo POSIX access to, some of these volumes. It is you know, a relatively low level command within the Linux environment, Unix environment, but it only can see and can only interact with data volumes that are mounted directly onto whatever computer you're working on. What if we want to look at things that are beyond the computer that we're logged into? We want to look at those large storage elements that are available both at Fermilab, but maybe also available at CERN or in the UK or in Canada. So one of the tools that we can use is a command called IFDH. So it is a data handling command that, if you haven't come across it, you will soon come across it. It stands for the Intensity Frontier Data Handling. It's pretty straightforward. And it is a tool suite that facilitates selecting the appropriate data transfer method from many possibilities, while also protecting the shared resources from overload. So you may know that you want to go and access something on Dcache, be that Dcache, as I said, at Fermilab or at another storage element, or something on EOS at CERN, but you don't necessarily want to have to dig in and find out, should I access it via XrootD? Should I access it via GridFTP? The nice thing is that IFDH will help you find the right transfer protocol, and in order to get over to that remote storage element and then get the information back, either the actual file itself or just information about the file. So we're going to be using IFDHC, where the C stands for client. So you have the package itself is called IFDH, but then the client is IFDHC. So I'm going to show you an example of a copy file. You should remember the mission setup, I believe, had you logging into the GPVMs, and this set up the DUNE TPC version. And we're going to do basically 5 commands. The first one, this one right here, we source a setup script that enables us to access a UPS products area that's on CVMFS. CVMFS being the CERN virtual machine file system. It is a mount point that is pretty much going to be located on almost any particle physics machine or open science grid machine anywhere in the world, or WLCG, World LHC Computing Grid. Any of those has a CVMFS mount point on it. Whether or not it has, say, the DUNE OpenScienceGrid.org directory is another question, but in general, it is going to have them. So I'm now going to bring up a terminal, and I will try and share my terminal with you. But I gotta get everything on the same screen. So And Jake is correct. You can get it on your own computer. I am going to share my, well, yeah. I'm going to change my screen to my terminal real quick. And this is my laptop, or actually this is my desktop. And one of the things that you'll notice right here is CBMFS is in fact a mount point in the root directory of my desktop machine. And I have,
and there are instructions on how to mount it on a Unix
That's correct.
machine.
Yep. So, but instead I'm going to generate my Kerberos ticket for Fermilab. I'm going to log into DUNE GPVM08. As I said, that one's my favorite. And then I'm going to start going through these commands. I want you to follow along. So I'm setting up the Larsoft and the DUNE UPS areas. We can talk about UPS in a little while, but basically it is a directory on CBMFS that has all of the packages that we want, software packages that we want to distribute around to the Open Science Grid and the WLCG. I am going to set up a specific version of DUNE. So I didn't follow the mission setup, so I apologize. So I have to do that by hand. And then I'm going to set up Fermilab security. So I already have a ticket. I did try to check out these commands ahead of time to make sure that they work. So I already have a ticket on DUNE GPVM08. And then the fourth command that I'm going to do is this command right here, which is a command that's only available on the interactive nodes if you've set up DUNE TPC software right now. That may change where it's packaged up and where it's included. But in general, right now, you need to have DUNE TPC set up ahead of time. And what it's doing is it's going and it's looking at this file. It's got this really long directory path. But the important thing to note is this right here. So I want to look at a file that is in PNFS DUNE tape backed, right? So this is tape backed dcache. And I want to understand what is the cache state of it. Is this file on tape only, or is this file on disk and on tape? Because if it's on disk already, then I can copy it immediately. I don't have to wait for the file to come out of the tape library. The problem, if the file isn't on disk already, what physically has to happen is the command goes to the tape library and a little robot moves around, finds the physical tape that the file is located on, picks it up, swings around the library, moves it, I don't know, anywhere from 20 to 60 feet, and then puts it into a drive. And then that tape goes into that that reading drive, and then the data gets streamed off of the tape and put onto disk. So I wanted to check the cache state of this. Hey, it's cached, it's available on disk. And so now what I can do is I can give an IFDHCP command. So it's IFDH space CP. So I want it to copy, and I'm giving a location, and then I'm telling it to copy it to that that place, dev null. Anybody not know what dev null is?
So Kirby, we can't really, at least in my window, I can't see the bottom line. It's being obscured by the Zoom window.
Oh, is it? Huh.
It's like my blackboard in my classroom.
If you can't, if that's the problem, try getting out of full screen.
I'm not in full screen.
Oh, okay.
Maybe
how about
Kirby
now?
gets out of full screen.
That works.
Yeah. Yeah.
There we go.
But yeah, that's a problem.
So here, IFDH, CP, and then the first file, and then the location that I want to transfer it to. And in this case, it's dev null. And so it, sure enough, it copies 0 bytes, puts it into dev null because, well, you know. But what you can do is you can, obviously this location could be any location, could be another location on Dcache. So could be moving it to persistent. It could be moving it to your local hard drive. I would not suggest trying to copy a 2 GB a full reconstructed Monte Carlo file and put it onto like your home area, but you might want to put that onto app to run over it interactively. That's a reasonable thing to do. The nice thing is
App.
Yeah.
Put it in data. But
or
don't
put it in data.
Yeah.
It's a better usage.
app is too small for people who use data files. Put data files in there.
You'll end up running out of your quota. The only person that you'll hurt or you will interrupt their workflow is yourself because of the quotas on app and what have you. But Tom is correct. Much better to put it on data than to put it on app.
The app quotas are oversubscribed. We have a lot more users times the quota than the actual size of the app. So it has filled up in the past. And we've asked for more, but they tend to grumble about that.
So what would happen if you tried to IFDHCP that file and it was not cached? What would actually end up happening is the command would go ahead, you would issue the command. IFDH would reach out to the storage element, the tape back Dcache, and say, hey, by the way, can you hand me back this file? Dcache would say, yeah, sure, no problem. Can you give me a little bit of time? I'm going to go and try and find that file off of tape, hang out here and just wait. So it doesn't give an error. It doesn't give success. It just puts you into a wait state. And eventually, if the tape drives aren't busy at all, if they were idle, then you might get that file back in 5 or 10 minutes. If they are very busy, you might wait 3 or 4 days or a week, right? And that whole time, that IFDHCP command is going to be sitting there stalled, and it will eventually time out. But unfortunately, depending on how you have it configured, it could time out, but then it might retry. And when it does retry, it will extend the timeout to a longer period. And so you should understand how long your timeout limit is for the IFDH command, and then also whether or not you have enabled retries. So when you try to copy a file that isn't staged, you will start the process of getting it staged to disk, but there is no guarantee on how fast that will happen and whether or not your actual copy command will have timed out or retry or what have you. So one of the big issues can be if you try and submit a job that is processing a file that isn't staged, what's going to end up happening, you submit a grid job, it goes out, it gets to the point where it says, hey, I want to start reading this file. It uses IFDH to get access to that. And then it just waits. And so you end up causing a grid worker node to sit idle for anywhere from 5 or 10 minutes if the tape drives were completely idle, or all the way until the timeout period plus all of the retries with the extended timeouts, or until the file actually shows up. So it's checking to make sure what the cache status of a file is a really important thing to do before you start processing. Yes, you would get feedback from a grid job that you did something wrong. One, in the fact that the IFDH CP command would fail, and so your job would report back that it had failed. But you're going to have to dig into the log files to actually see what the failure mode was. So it's not as though the grid job is going to automatically tell you, hey, you forgot to stage this file. And oh, by the way, if you don't check the logs for 24 hours, you may go and look at the file that it failed on and say, hey, well, it's staged now. So there, the system itself is in a continuous state of flux. So what may have been a problem when you submitted the job and it got to go run on a worker node is not necessarily how things go. An excellent question. So what is the correct way to call a file that is not cached? We will get to that in part 2, data management. So, but an excellent question. For now, let's Let me switch back over to here. So exercise number 2, using the IFDH command, there are 4 tasks. So we wanted you to create a directory in your Dcache scratch area. Specifically this one, if it doesn't exist. This one you may need to create. But create a directory called DUNE tutorial December 2021. Also, I should note right here, this link, these resources, is all of the IFDH commands. So there's IFDHCP, which is a very common one. But if we go down lower, you'll see that there's like IFDH move, IFDH ls, IFDH make dir, IFDH rm, IFDH rm directory, all of those things. So I will let you guys go and do that for a little while. And let me know, give a thumbs up when you've completed. A link for this slide, sure.
Yeah, actually,
I'm gonna put
Matthew,
that in
the GitHub now has a link off the Indico as well. But yes. Well, the GitHub has a link off the Indico, not the other way around. Very confusing. Yeah, a question for the really new people. Are you people who haven't used Fermilab computing before? Are you completely lost or just partially lost?
For me, yeah, I'm using the Fermilab, so I already have the account access.
Oh, okay.
Yeah,
That's good.
yeah. So I mean, there are a lot of things I already did it. Yeah, especially the setup, don't setup, that's already done. So
Okay.
yeah.
Yeah.
This is my first time. This is my first time using Fermilab or CERN, so it's kind of confusing, but I'm getting the hang of it.
Yeah, this is because we're working on actually developing software. We're taking you guys, into a bit more detail than people always get on this. And I think any comments you have on how to make it clearer would be very useful. Kirby's doing a really good job, but there's always things we leave out. There's just so many, I want a picture of all of this somehow.
Oh man, we're 2 minutes over already. Okay.
Well, you got lots of time. Well, maybe.
Kirby, you have the quiz ready. So
Oh, you do? Okay.
yeah. So yeah. But yeah, so we have a couple of thumbs up. So some people are thank you
Okay.
for giving us feedback. That's important. Yeah.
So not to hijack the whole process or not give you enough time, but I will show you how I did this real quick. So here are the commands. The first one that I did was I had actually had to make my user area. Then I made IFDH make dir for the tutorial. I copied the file and then I gave a destination name. The one thing that you may or may not be familiar with is that you need to give the full path for both the source file and the directory. Sorry, the source file and the destination. If you want to give a directory, you need to give the -D option on your IFDHCP. So I didn't show that, but that's the thing to remember. I then copied it to dev null, which is just, doing that. I tried to remove the directory because that was the next task. Good thing, bad thing, it told me it's not empty. So it failed. So that was the exception. And it gave me an error flag of 1. So I said, oh, okay, well, let me just ifdhrm dir.bash rc. And then I was also reminded that is not a directory. So I had to remove the file first using rm, and then I could remove the actual directory itself. So does that make sense to everybody? Yeah, cool. Okay. The next thing, talking about storage spaces that we want to talk about. So I showed you IFDH, which in general is a great tool to create directories, to copy files, move things around. But what if you want to access a file? Really, the best way to do a scalable accessing of a file that we know of right now is XrootD. So this is the extended root daemon. So it's a software framework designed for accessing data from various architectures in a scalable way. It is most suitable for read-only data access. So you want to read something, great, fantastic. You want to stream a file to, you want to stream 1,000 files to 1,000 different grid jobs, XrootD is the key. But the question is how do I get from this right here? Also, I now realize
We are seeing
why I
your
had to-
terminal. Yeah.
Sorry, yeah, okay. Here we go. So how do I get from this location, which is a mount point on a GPVM, to an XrootD directory? The nice thing is we have a tool for that, PNFS to XrootD. You type in PNFS DUNE scratch users and then your username, and it will give you back an XrootD location for that. So if you want to go ahead and give that command, I can actually show you what it looks like real quick. If I switch back over. So this is now an XrootD URI. The thing that you will note, it has a server in front of it. So it's a root server. And then it has the directory at the end of it, which looks kind of familiar to what you've seen above, but it has this fnal.gov inserted in between fnal.gov/users in between PNFS and DUNE. But the great thing is we can take that, we can then actually start to use XrootD to do some of the other commands that we were using with IFDH. So an example right here, we can do XrootD FS, which is the file system command. You give it the server name, and then you give it ls, and then the directory you want a listing of. And now all of a sudden, I get the listing of what's in that directory on the dcast scratch area. But I'm doing all of this in a location independent manner, meaning that if I did this in a scalable way, if I did this on a grid worker node, if I did this on an interactive node, all of those things, everything would behave exactly the same, and you're not going to run any conflicts or problems getting access to that. Of course, XrootD FS has a bunch of other commands. So it can do ls, it can do copy, things like that. It gives you a lot of tools that you can use. So in the last exercise for this part, if we go back. So IFDH, I showed you that long list of commands. One of them is locate file. So we have a file right here. So maybe somebody gives you a file name and says, hey, this is the latest Proto-DUNE data with the, the top electronics for the vertical drift cold box. And we need to know what the noise levels are immediately. All I have is the file name. And you're like, okay, I can't locate that. Well, you can use IFDH to locate it. And if it's registered in our file catalog, we can get that information back. Take that location, translate it into an XrootD URI, then use XrootD copy to copy that file to dev null, but then also do an ls for the directory that file was in and count the number of files in there. You may need this little trick right here. So you can pipe standard output into the WC -L command and it'll count the number of lines. So as an example, you might do ls of your home area and then pipe word count -L and it'll count the lines, the number of files. So I'll let you guys play with that for a little while before we move on. And that was definitely throwing a lot at you. IFDH, going from IFDH to XrootD FS is a lot. And but I have full confidence in you that this can work.
There is a question from the boss. Does XrootD act similarly to IFDH, or are they evil consequences? I don't know about from using it.
XrootD is no, it is different than IFDH CP. The one thing about XrootD CP is that you have to be going through an XrootD. That is strange. Do you have DUNE TPC set up? Sorry, I'm replying to Matthew right now,
No,
as opposed to the question.
I missed it, Matthew.
Oh,
Yeah, this is a hijack of Matthew Mitchell.
oh, that's a hijack.
Yeah, you can
okay,
change your
excellent.
name on the Zoom if you want. You can't change the picture probably, but you can change you can edit your name. Yeah.
Sorry for that. I don't know. I got an email. I log in and it's like it's Polish.
So the one thing that if let me do a new share real quick. Or change my share. So the one thing that you definitely need to do, let me clear before you get. So you need to do this command, source CVMFS DUNE, which is up above.
Okay, let me do that. Yeah.
And then set up DUNE TPC. And without those set up, then these tools, these software tools, data management tools are not in the shell and not in the environment and in the path to be executed. So,
okay, yeah.
So real quick, going back to the question of IFDH CP versus XrootD CP. IFDH CP is a wrapper that can utilize XrootD, but it can also utilize grid FTP and SRM commands, whereas XrootD is just using XrootD, right? IFDH is kind of a layer on top of, well, not necessarily on top of, but it utilizes some of the XrootD libraries and tools. So if you know that XrootD is definitely the thing that you want to use, you're confident, you know that that's definitely what you should be doing, go ahead and go for XrootD. That's fine. If you're unsure, you may be trying to access a storage element that you just don't know what the transfer protocols available there are, then you might instead want to use IFDH. SAMWeb to XrootD. I think actually PNFS to so SAMWeb to XrootD is different because I believe SAMWeb to XrootD takes in the file name as opposed to PNFS to XrootD takes in the full path and the file name. IFDH locate file, I believe, does use SAM. But yeah, I believe it does.
People don't know what SAM is yet, though. So maybe some of these questions might need to be asked later.
And
Will
I
it work
just
when we
want to
switch
say-
to?
Oh, for me, it's working. I figured it out.
I just want to say that I'm trying to write all of the questions that you're asking on the chat, write them on the live doc, and then we'll just work over answers so that you can actually get proper answers after that tutorial. I tried to write notes when Kirby is talking, but this is limited, right? So Kirby, you can have a look, but yeah, I tried to transfer most of the questions, so then it doesn't get lost with the chats being killed once Zoom is over.
When you
so
record, it records the chat too.
Sure.
So Tom brings up a point. IFDH locate file does depend on the fact that does require that the file be registered in the SAM metadata catalog. PNFS to XrootD does not depend upon that. So if you have a file and you know the PNFS path for it, you can use PNFS to XrootD. That will always work. If you have a file, whether the file is in SAM or not, it is in the file catalog. If you want to use SAMWeb to XrootD, then the file needs to be in SAM. And if you want to use IFDH locate file, you also need to have it be registered in SAM. So, yeah. And this is going to transition nicely into the next part of the tutorial, which is all about SAM, but I don't want to move too fast.
So Kirby, just to be clear, it doesn't depend on the particular implementation of the metadata then. So Metacat will work too, seamlessly when we switch.
Seamlessly is a bold statement that I'm not willing to make right now.
Okay.
But in general, IFDH, we will make sure that IFDH does have an implementation that will allow you to access the Metacat. Yeah.
Awesome. Cool. Thanks.
Yeah, just for the new people, we're showing you what works now, and part of all of our job is to implement the new version of what's going forward. And so identifying flaws and pictures and questions about this is actually part of the development project.
Yeah. So understand what's working right now, and how it works, what its point is, so that we know what we're going to change.
It's all perfect.
Yes.
Now that you've given us 2 extra petabytes of disk,
It will definitely help. Does anybody have an answer for how many other files are in the same directory? I don't.
oh, you mean how to find it?
278. There's excellent. That sounds about right.
Yeah.
unless, well, anybody else get a different number? I'm just curious to know if someone got a different number, because yours is, you know, generator level truth. You answered first. So they might need to go back through their workflow and do some validation. Okay. I think I've only got about 22 minutes to get through all the SAM stuff. This is going to be
Yeah, you can do
fast.
it.
And they will
So
be
they're
the
gonna
quiz,
need to
but I
read.
think there will be a bit of a break before the quiz, so then people can digest all of the materials and so.
So
I
just
think
real
you're
quick.
fine.
Okay. Key points. Home directories are centrally managed by computing division and meant to store setup scripts or oh, that's right. I didn't correct that. It is not supposed to store certificates. Network attached storage is DUNE app is primarily for code development. DUNE data is to store n tuples and small data sets. Dcache volumes offer large storage with various retention lifetimes, and IFDH and XrootD allow for accessing data on Dcache and robust transfer methods in a scalable way. I didn't say it all that much. Trying to do a CP command over in or out of a PNFS directory is a bad idea unless you're using IFDH CP or XrootD CP. So don't just do a CP or an LS of those areas. Always try and use either XrootD or IFDH, because as I mentioned, these are those large storage volumes. They are a little bit more delicate, and very specifically, the mount points on the GPVMs, those are very delicate and are very much susceptible to crashing. But if you go through IFDH or go through XrootD, you'll be totally fine.
Yeah, your colleagues will not be happy with you if you hang up a GPVM by doing direct NFS transactions with the persistent.
Exactly. So, any last questions before we move on from storage spaces? Going
I think
once?
we will move
Going
on. But
twice?
I want to reiterate that there is the live doc. So then if you, it may be better to manage than the chat on the Zoom, which I manage both.